All right, day one of learning R programming. I'm going to be walking through some very basic things such as data types and data structures. And basically what data types and data structures are, it's the way that R, the programming language, handles its data and defines the data. So let's jump in to learning how to program in R by looking at data types and data structures. So if we look right here, these are the 5 most used data types. There are more than this, but these are the most common and the most useful. So beginning with the first one, my char. So that's short for my character. That's a variable that I've named. And basically it's anything of a string type. And so as you can see here, my char equals the letter A. It doesn't have to be a single letter. It can be a full sentence, whatever it is. It has to be enclosed with quotations. So these are what are called strings or characters. Now here, my num. Again, this is a variable that I've named my num, and it's short for my numeric variable. And this is a number variable that holds numbers that have decimal places as well. My int stands for my integer, and I've created that because an integer has to be a whole number. Unlike the numeric variables, it cannot hold decimals. It has to hold whole numbers. Finally here, my logic. So my logic is either a true or a false. So if we run this, we see it's kind of stored in your history over here. These are all the commands you've run. These are the variables that you're saving in here. So if you see right now it's set to true, I can come over here, change it to false, and it rewrites whatever is there. And so this is a binary existence. It's either on or off, true or false. And with R, it is case sensitive. You have to put all caps for this logical variable data type to work. Now my factors are a little unique to R programming, and what a factor is basically a categorical variable. It's a category, and so it's something that if you're working with data, it'll come up frequently, and you don't want to treat it as a character, because characters are usually a character variable because it's usually a unique statement. Like think about first names. Generally first names can be unique. There are repetitive cases of names like the name John, but when you're doing data analysis, first names are usually important to keep unique, whereas factors such as North America, South America, Europe, or Asia, whatever it may be that you're working with, you want to keep them in categories, and R will handle those categories really well, and we'll be able to see a lot more of the power of factors as we move on. And if you look over here, factor with 4 levels, and the levels meaning categories. So it has 4 categories within this factor called my factors. So to be better with this, we could rename this and say regions. And that would be a little more descriptive to know what factors, what categories are contained within this variable. Now rarely are you going to be working with data that's a single variable that you're interested in. You're looking at massive amounts of data or a small amount of data, but regardless, it's more than one variable that you're holding. And so what's important is to know how to use these variables together and to analyze more than one of them at a time. Otherwise you can't really analyze it. So let's go ahead and look at matrices, arrays, and lists and vectors. These are data structures. Now the way that a data structure is different from a data type is that, like I said, a data type holds a single value. It holds a single variable. A data structure, on the other hand, will hold multiple variables, and depending on what type of data structure it is, you can or cannot combine multiple types of data. So multiple types meaning, going back here, multiple character variables or more multiple numeric variables. So let's go ahead and dive in so that you understand what we're talking about. So a vector, to begin with, is a single vector. It's one-dimensional with a single type. So what I mean by this is that it has to have a single type. It has to have only one of these types. It can hold as many numerics as you want it to hold. It can hold as many integers, as many true-false logic data types, but it has to be a single type. Now to get to know these data structures better, one thing you can do is use this question mark vector. And you can do that with a lot of different things if you're curious about what they are. Just type the question mark and then type whatever you're curious about, and R will do its best to find it. So I put it here, and what I'm doing, I'm pressing Command Enter, little shortcut. I'm on a Mac, and so that is what the command is. I'm not sure what it is for Windows, maybe Control Enter. And as you can see over here, R has been helpful and pulls up the documentation for a vector. And you can see how to use it. You can convert things as vector, you can check if it is a vector, and most importantly, you can create a vector right here. So let's go ahead and this isn't the only way to create a vector. We're going to jump in to see how to do that, as you see right here. So I called it my vector, and to create a series of numbers or a series of variables, whether they're numbers or characters, you have to use this funny little function. And this function, this C, the letter C, stands for combine. And it's going to combine whatever is between the parentheses. And I don't mean combine as in add, I mean combine as in it's going to put it into a vector. And we're going to be able to see those put together. It's now in a structure. So the question mark str, that stands for structure. We want to know what structure whatever we're looking at is. So it displays the structure of an arbitrary R object. So if we do str and pass that function my vector, it'll come back and it'll say it's numeric, it's a numeric vector, and it has a series of 1 through 4, so it has 4 total variables, and here they are. And also let's look at summary. So the summary, generic function produce result summaries of modeling the fitting functions. So let's run that so you can visualize what it brings up. So as you can see, if you're working with lots of data, this is super helpful because I'm only working with 4 variables here and it's not too complicated. But it gives you just the spread of numeric variables. It'll work different when you run it on different types of data, but when you're running it on numbers, it'll give you this spread. And it's really handy when you're getting to know your data in the beginning of the data analysis process. And lastly, when we say my vector and we do the brackets with a number in there, as you can see down here, it brought back 15. And 15 is the second item in there. So you could really do my vector, get the last item in there. And what happens when you do that? When you put something that is beyond the bounds of the vector you have, you get the NA. It doesn't exist, not available. So that's a basic overview of vectors. Let's go ahead and look at a matrix data structure. A matrix is similar to a vector, but the difference is that it's multidimensional. It has 2 dimensions, which means it has rows and columns now. It's basically a combination of multiple vectors. So again, if we pull up the documentation, we can see that it creates a matrix for the set of values. And we can create it by passing the data, so calling matrix, passing the data, and defining some of these other variables. And if you don't know what these variables are, it's easy to find out because it tells you right down here what these arguments, what these parameters are. So we know by this that n row is the desired number of columns and n column the desired number of columns. So this documentation is helpful to get us up and running quickly. So let's go back here and let's say call it my matrix. And we're going to call matrix because we want it specifically to be a matrix. The default is a vector up here, right? So we want to force it to be a matrix. So again, we call combine. We want to combine all these numbers together. And n row, if you look down here, the desired number of rows, we want 3 rows and 3 columns. So let's go ahead and run that and create my matrix. And let's look at it down here. Okay, so it has 3 rows and 3 columns. Now this is important that you can still call the summary matrix, the summary function, even though it's not a vector. You can pass a lot of different things into the summary function, and it'll help you understand your data. So V1, V2, and V3, it went ahead and it looked at each vector. The vector is held by columns. So you could split this out and have each column be its own vector, and that's the way summary analyzed it. And again, it's going to say it's a numeric matrix, and it has 3 rows and 3 columns, and here are the values for it. So now let's go ahead and change it a little bit and say we're going to add another parameter in here, ByRow, true. So if we come over here and see ByRow, we know it's a logical argument, and the default is false. And so it's naturally filled by columns, as we saw over here when we ran the summary function. It evaluated it in the columns. And so if we want to avoid that, we can say ByRow equals true. So if you look, it looks almost the same, but it changed how it placed the variables within the matrix. As you can see, it's not 1, 2, 3, 4, 5, 6. Now it's 1, 2, 3, 4, 5, 6 going horizontal instead of vertical. And the summary function will now run it differently. It now has different results, 1, 4, 7, 2, 5, 8, instead of 1, 2, 3, 4, 5, 6. So the vectors are still in the columns, but you decided to place the values in a different order. So now let's retrieve some items, some single items from the matrix that you might want to pull from. So my matrix, and when you're pulling items from a matrix or from a different data structure that we'll go over later, you specify by saying what row and what column you want. So you're targeting a specific item, kind of like with crosshairs, to pull that item back. So when we say my matrix brackets 2 comma 2, we're going to get 5. That's right in the middle. So as you can see, 2 comma 2, and they meet right there at the 5. Now my matrix, and if you leave out this row indicator and you do comma 3, let's see what it pulls back. 3, 6, and 9. So basically, we told it to go back to this matrix and just pull back this last column, and you want all of it. You want all the rows. So when you leave it blank, you're saying, I want everything back. It's not that you're saying you don't want anything and I'm going to leave it out because otherwise you wouldn't be running the command. But it's saying, I want everything, and I want specifically everything from the 3rd column. And the opposite works as well when you want the whole row. You say I want the first row and I want everything in the columns. So 1, 2, 3, and you got it right here. 1, 2, 3. And lastly, my matrix, let's run that, and you get 3. So why did it pull back 3 here? It's because the number 3 essentially has the index number of 7. If we look here, it's 1, 2, 3, 4, 5, 6, 7. So here we are in the 7th position in the matrix, and we pulled back the value of 3. Now let's say we want to retrieve multiple items from a matrix. Just like we've seen this function before, the combine. So my matrix, combine 1 and 3. Now, what do you think this is going to do? Well, let's go ahead and run it. It pulled back the first column and the third column. 1, 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. And it's important that you put this comma here, because even if you want all of it, let's say you run that. It brought back the index of 1 and 3, and so those values are 1 and 7. So now, again, if we look at it the opposite way, if you want to pull separate columns, here you have it, pull 2 and 3. Now this could probably be done a better way. If you do my matrix, and you want all the rows, so I'm going to leave that first part blank and put the comma. I'm going to put 2 through 3. This colon specifies that you want everything in between there. So if I run that, it gave me the same results. And the same goes for the rows. You can say rows 1 through 2. Now, some of the benefits of using a matrix is that since they are all one data type, if you remember from up here, it's a single type with multiple dimensions. And that just means it has rows and columns, right? Well, if we go down here, it's a benefit because you can have lots of uniform data and you can perform massive operations very quickly. And one of those functions, the way we do that is using apply. So I'm going to create a really big matrix so I can perform some big calculations on it. And just to walk you through what I'm doing here, I'm forcing it to be a matrix by calling the matrix function. I'm saying combine, and then I'm creating a sequence, SEQ. Again, if you're curious about that, type in $SEQ and it'll bring up the documentation. So basically, I'm saying make a sequence from the number -98 to 100 and count by 2. And I want 10 rows and I want 10 columns. So if I run that, you'll see that it brings back a nicely shaped matrix for me with lots of good numbers to work with. So let's go ahead and see what I meant when I said you can perform massive operations quickly. Using the apply function, apply functions over array margins, meaning you can apply lots of different things. You can apply functions and mathematical operations over large sets of data. So apply, we're going to toss in and pass it my big matrix. And this 2, it's either 1 or 2. You say, I want to do that to the columns or the rows. The rows are number 1. The columns are number 2. And I want you to find the mean. So it has some saved functions in here that it can apply. So if you look down here, we've pulled it out and it looks like the mean for these columns is as shown. It's 89 for this and 69, 49. So it's super helpful when you want to do some quick calculations. Now let's sum all the rows. So this time it went horizontally and added them all up, and these are the results that we got there. You can even toss in a custom function. I won't go into the specifics with this for the sake of simplicity, but basically it's saying I want to apply whatever I do here to the big matrix, and I want to do it on the rows. And I'm calculating the mean of everything that is over 0. That it's basically everything that's a positive number. So if you see down here, I found the mean of everything that's a positive number, which is basically, all the rows that have positive numbers. So I ignored pretty much this left half of the matrix and just found the means of the items right here. So again, it's very helpful if you want to perform massive mathematical operations quickly across a bunch of numbers. A matrix is helpful to do that. Now let's take a look at a list data structure. It's a one-dimensional data structure, and it can hold multiple types. So let's go ahead and see what we mean by that. Here's a very simple list. I'll call it my list. And again, I want to force it to be a list. So I'm going to call the function list. And this is what I'm passing in. It looks random because it really is. I'm passing in a character data type, passing in a 2, which is a numeric data type, and I'm passing in a logical variable. Let's pass that in. And let's look at my list. Look, 2, true. So we got everything in there, and it's just kind of random. It holds whatever you put in there, and it doesn't care what data type it is. So you can make a list of other data structures as well. You can have a list of vectors, a list of matrices, and it could be pretty powerful. So let's go ahead and make a list of vectors. And each of these vectors will have different lengths, different data types, whatever it may be. And for simplicity, I just created these kind of bogus data, and I'm just going to go down and run each one of these. And now when we come to X, I'm going to create a list of all these things above. And so I'm passing in the variable n here, s, b, and finally I'm passing in a 3. Why? Because it's a list, and I can do that. It lets me do anything. So let's go ahead and look at X. All right, so here we have it. A bunch of random junk that we threw into the list. Now it's helpful because it can hold everything. It might be hard to work with later, but continue and see what else we can do with the list. Now list slicing, I'm not going to go over that right now, but basically you can slice and dice it just like we did with a matrix up here. It takes a little bit more specific syntax to understand what's going on there. I'll show you my list is the one we created up here. Took the second index and it's a 2, so it pulled back that. An X, 3, so it pulled back basically the third item in there. So it's pretty helpful. So now let's look at, let's say you have these lists and you want to name what they are. So I'm going to create a new list called V, force it to be a list, and I'm going to say Bob equals combine 2, 3, and 5. And I'm going to say John equals combine double A and double B as characters. Now let's go ahead and see what it looks like on the other end. So now, instead of these lists having, if you look up here, they just had kind of these random indexes. Part 1, Part 2, Part 3. We now gave them a name, so they're a little more easy to access. So if you come down here and you say V, you can use the $sign and it'll pull up the different items in the list, the different collections, you could say. So you say V $sign Bob, and it brings back everything that Bob was holding. And V $sign John brought back everything John is holding. Now lists, they're good, they can hold a lot of things, but they really have their drawbacks because the data is inherently less organized and harder to work with. And for that, because of that reason, most people prefer data frames when doing data analysis because it forces you to follow some rules, and by following those rules, it makes data analysis a heck of a lot easier. And so we're going to go into that in the next video. But before we jump into that, look over at your environment tab. It's basically saved everything that you've done, and it's telling you these are the variables that you have access to. And this will carry over no matter what file you're looking at. These are available. This is the environment for RStudio, not just these files. So you can see them here, and also if you come down here and run ls, it'll show you all the names of the data structures or data types that you've created. So it's very helpful to know, to keep track of what's going on. So jump in the next video to see what we're going to be doing next when we talk about combining vectors into a data frame to make data analysis a heck of a lot easier